Hello, my name is Jacob Stoebel, and this screencast is about my work with codeworkout. Codeworkout is an open source Rails project originating out of Virginia Tech. Its purpose is threefold. One, to help new programmers improve their skills with short programming workouts. Two, to provide a learning platform for professors to host in-class assignments and be able to easily assess their students' progress. And three, to provide a platform for data collection on the behavior of new programmers and how they approach challenging problems. I was a member of a 6-person team in my class, Software Engineering at Berea College. We chose codeworkout as our project for the semester with the hope to make a meaningful contribution to the codebase. The project's lead, Steve Edwards, charged us to create a Q&A forum for the site. They wanted something similar to Stack Overflow, where students could ask questions when they got stuck and others could post possible solutions. We wanted this forum to create a community of new programmers who can all support one another in a low-stakes environment. After all, when you're stuck, it's easier to ask your peers than an instructor. We also wanted to reduce the chance of feeling dumb, and I use that phrase in quotes. If you can ask your question from the comfort of your home rather than in front of your peers in class, you're more likely to speak up. Larger programmer communities like Stack Overflow sometimes discourage newbie questions, and we wanted this to be a welcome alternative. Finally, instructors can easily assess the progress of their class by seeing what students have questions about. In order to be successful on this project, we as a team needed tools and a workflow to stay in sync with each other in a distributed environment. We needed to make sure that the expectations of our project weren't broken after merging in new code. We had to demonstrate to the team lead that we had thought through our design thoroughly. And finally, we needed a relatively smooth way to hand off our work to the upstream repository. Fortunately, a strong set of unit tests for our work were able to help with all of these needs. codeworkout uses RSpec for all of its tests. RSpec is a comprehensive Ruby testing framework with excellent integration for Rails. I have to say, it was a real joy to work with. One of the first things I fell in love with was the fact that it is so easy to read. As you can see from this example, the expectations for the tests shown here are clearly spelled out. But RSpec is more than tests, and this is reflected in the word choice the framework uses: specs. If you want to know what a piece of code is expected to accomplish, just read the specs. RSpec specs serve as both unit tests and documentation. RSpec is also extremely dry, which stands for don't repeat yourself. If you have multiple specs on the same block of code, RSpec provides some great tools for defining the commonalities across multiple specs that you can then reference whenever you like. As an example, let's take a look at a single user story. The story is, users should be able to update a question they have posted. When a request comes into this controller action, the appropriate question is pulled from the database. We authorize the user's permission to update the question. The posted parameters are assigned to the active record object, and a save is attempted. Assuming the save is successful, the user is redirected and a confirmation message is displayed. And if the save was not successful due to bad parameters, the form to edit the question is re-rendered and an error message is displayed. Here's the set of specs that I've defined for the questions controller. The first thing to note here is the before block, which I've defined at the top. This allows me to define any code that should be run before any individual test. In this set of tests, we are using the factory girl gem to populate the necessary database tables. Once a test is done, the database is rolled back and we repeat the process for the next test. This is to ensure that when one test alters the state of the database, it will not have unintended consequences on the following tests. Jumping to the spec in question, this update action requires a user be signed in, which means that we need a way to simulate the logging in of an appropriate user. To make things more complicated, codeworkout has 3 types of users: admins, instructors, and regular users, which are students. Each have differently defined abilities. In order to keep things dry, we should ideally be able to iterate over each user role, identify a user with that role, and then run tests as that user. codeworkout uses the devise gem, a popular framework for authentication. Devise comes with some helper methods for testing logging in a user. Here I've defined a macro, which is simply a module to provide supporting methods to my specs. I've defined a method loginAs that accepts a role name as a string. When the method is called, a user is found in the database matching that role, and devise logs them in. We save that user record as an instance variable so we have access to it later. Once that user is logged in, we are going to define some parameters. The method let allows us to define variables that are lazy loaded, meaning that Ruby won't actually execute them until they are needed. Here, I create a new question using factory girl that belongs to the user I just logged in. Then, I define a new hash to represent a parameter on the question I want to update. Specifically, I'm changing the question's title to the string new title. I then merge that change into a full set of parameters to be posted to the update action. Finally, I initiate the HTTP post request. Just like let lets us lazily define a variable, subject lets us lazily define a block of code that is run whenever we call it. The whole point of this is that I've done all of my setup just once. For each test inside this spec, I simply call post update, and the HTTP request is made. Now, I simply make assertions to test each expectation of the controller. I expect that the user will be redirected to index. I expect that the record will be updated, and I expect that a flash message will display confirmation. All of this should constitute a full set of expectations for how the happy path of this controller action should run. But what about the sad path, or the code that runs when a user, for example, does not have permission to update a question? I've created a separate spec for this. The exciting thing here is the setup is almost exactly the same. The only difference is that I define a new user who will for sure not be the one that's logged in, and then I create a question for them. Then I attempt to change the record in the exact same way. This time I expect the request to cause a raised exception at the authorization layer due to the question not belonging to the user. Specifically, the user should be redirected to the home page and an error message should be displayed. When I'm ready, I can run my tests from the command line. Each of those green dots represents a successful test run. If tests fail or cause an error, I'm given a report with a traceback, making it relatively painless to debug. And that's it. So in conclusion, a test suite gives us the ability to define every expectation we have on a program. When the program changes, we use the test suite to assure that no expectations are broken before we check in our changes into source control. Thanks for watching.